Next topic in the GOC, such as method of purification. Here, the purification means the pure compound from there is a impure mixer, impure mixer. Okay, so the pure compound is obtained from the impure mixer. Okay, so we can there is a impure mixer. We can reduce the impurity. This is a reduce impurity or there is a gagu or dust particle. They have reduced the actual concentration of purity increases in the compound. Okay. So these purification techniques, around there is a five types. One is first is a crystallization technique, crystallization, and then second one is there is sublimation, and the third one such as uh, extraction, or this is a solvent extraction. Okay, so then a fourth one such as distillation, and the fifth category that is for chromatography graphic technique. Okay, so this five category we can reduce the impurity and increase the concentration of organic compound or ore. Okay, so this is for GOC. So the purification, especially in the case of organic compound, because in this unit is organic, so this organic compound among these five types of techniques used for the purification. First case is a crystallization. Crystallization. This is actually the theoretical part. So just you should be understood what are the techniques, what is the process like that. That is enough. Okay, because when we clearly understood whatever the question asking, we can solve for that question. Okay, the crystallization, it is a actually the impure mixer can be dissolved in a suitable solvent. We get in the mixer of solution or liquid state. This is for there is a solid state. We can solid or liquid, whatever that the mixer impure mixer, we can dissolve in the suitable solvent with various concentration. We can get the solution. Okay, so actually this is for solute and this is for solvent. It gives a solution. So the solution we already studied in the case of dilute solution, concentrated solution, especially saturated, unsaturated, super saturated, like that in the solution unit. So the concentration of the solution as directly proportional of crystallization. Okay, crystallization. So the concentration in the case of concentration order in the case of the solutions, or first case as a super saturated solution, and second case as a saturated solution, and there is a unsaturated solution, lesser for there is a unsaturated solution. Okay, so this is the order, the concentration order, because whenever that in the solution of concentration increases, see this is a vessel containing the solution, especially supersaturated. Here the cation and anion, like that the ions are presented in the entire solution. So when we concentration increases, the interionic distance or decreases. So the interionic distance decreases, actual the attraction between the cation and anion increases. There is a cation and anion attraction or increases. So for that reason we can get in the pure crystal. Okay, so pure crystal form. Okay, so in generally the concentration of solution in case of supersaturated increases or highest, we taken as a supersaturated solution in the crystallization technique. Okay, so here the conditions, actually the solvent chosen for the solvent cannot be interact chemically with the solute, because the solvent, if they have reacted, the unnecessary unwanted product will be formed. So that's why the solvent chosen is very careful. Okay, another category, the evaporation of solvent also is a better way. The quickly evaporated solvent is chosen. Okay, so these are the crystallization technique, especially in the organic compound. For example, here the crystal, mostly the 100% is a pure compound is obtained. So here one drawback is that chosen solvent is very difficult with a suitable solute. For example, the chloroform, CCl4, benzene, acetone, dichloromethane, so alcohol, ether, water, even those all are there is a solvent. Depends on that solute, we can choose from that solvent. Next we go to the sublimation. The sublimation, there is a nothing but solid is directly converted to there is a gas in presence of thermal condition. That process are called there is a sublimation process. So here the solid as a impure. So we taken as a impure solid, applying the thermal energy, we can get in the gas. Okay, so this gas maximum that's a purest form. Okay, the gas is a maximum pure, because we know that every compound or there is a impurity or unnecessary metal or minerals, whatever that they have impurity, the different boiling point as well as melting point. So for that aspect, the impure solid, by applying the thermal energy, we can get the pure gas of the compound. Okay, so this gas after condensed or reducing the temperature, we can get the pure solid. Okay, so this is a simple aspect. In generally sublimation, nothing but the solid is directly converted to the gases in presence of thermal condition. This is for the sublimation. So for initially taken that a solid is a impure solid, by applying the thermal condition, we can convert it to there is a only pure sample or pure compound. Only there is a condensed, we can get the pure compound. Here the example, there is a naphthalene, then there is a benzoic acid, camphor. Okay, so etc. These all are, there is examples. These examples may be asking, otherwise this is not that much of important in this GOC unit. And next there is a extraction technique. This extraction techniques, actually this is a classical or there is a old method. Here we taken as a separating funnel. This separating funnel, it mixed the two immiscible liquid. Okay, there's a two immiscible liquid. For example, the immiscible means they have separating two layer. Here there is a higher density compound, dense compound containing a solution. Okay, so this is for there is a lighter dense compound of a solution. Okay, so whenever this the initially the compound is mixed with or prepared the solution. Compound is a solution prepared by addition of the compound, addition of the solvent, we can get the solution. So this solution we can add it to that another one solvent. So there the impure compound of the pure compound as well as the impurities, they have dissolved with the various solvent. For example, this is organic phase and aqueous phase. So considering here ethyl acetate, CH3, COO, C2H5 and H2O. This is for the organic phase. This is for the aqueous phase. Water has a higher density, so water soluble compound is come to here. Okay, so this come to here of water soluble compound, we can open this tab, we can collect this solution. Okay, here after that collection of this solution, go to distillation, we can get the pure compound. Okay, here one drawback, there is a handling of manual mistake is will more possible, because if careless handling, the upper liquid also will come. Okay, that is a drawback of extraction technique. Next we go to the distillation. This distillation is nothing but the impure liquid. By applying the thermal energy, we can get the purest form of vapor phase. This vapor phase after condensed or reducing the temperature, we can get the pure liquid. Okay, so this distillation is 5 types. One is a simple distillation. This simple distillation, the two component, actually for example A plus B, here there is a containing solution. Okay, this containing the solution. Here there is a boiling point of A is much more greater than boiling point of B. So is nothing but the two component, at least any one compound highest boiling point. So there is a boiling point differences whenever highest. We can separating the simple distillation technique, because these two is containing a solution A and B. Here A has a highest boiling point. So by applying here temperature or applying the thermal energy, first of all the vaporized compound or there's a B. Okay, because the vaporization is inverse of the boiling point. Whenever that boiling point decreases, the vaporization or increases. Okay, this is important. Okay, so for that reason, the A and B, the highest boiling point differences, we can separate in the simple distillation technique. After that, the purest form we can get in one by one. The next type, it's a fractional distillation. Okay, the second type here, fractional distillation. This fractional distillation, the distillation is simply saying the liquid is converted to the gaseous. After that, the gaseous is reducing the temperature or condensing the gas, will get the purest form of sample. Among the distillation, there is a 4 types. One is a simple distillation, and next is a fractional distillation. This fractional distillation is almost is more close of the boiling point. Okay, there's a more close of boiling point here. A plus B gives us a solution. Here the boiling point of A is almost equal to of boiling point of B. So whenever that similar like the compound, we can separating this fractional distillation. Here this is enough mostly, because the fractional distillation, the fractionating column are used. Fractionating column are used. For this fractionating column, that's most useful for the separation of the A and B. Next we go to the, there's a third one. It's a reduced pressure distillation. Reduced pressure using, there is a distillation. This method actually, whenever when the decomposition temperature is equal to, it's a boiling point. Decomposition temperature is equal to of boiling point. For that compound, we can using this reduced pressure. Actually, the pressure reduced is directly proportional of boiling point, or more easily boiling process. There's a boiling process. Okay, so for that reason, there is a the reduced pressure distillation is used. Actually, for example, A plus B gives us a solution. For the solutions containing A and B, if A containing or A has the boiling point 70 degrees Celsius as well as there is a decomposition point also 70 degrees Celsius decomposition temperature. If like that, the compound whenever that presented here, the pressure is reduced, the boiling point also increases. Okay, because the external pressure of atmospheric pressure, whatever that external pressure increases, the vapor pressure as well as boiling point also increases, sorry, decreases. Okay, okay. For that reason, the pressure of reduced is directly proportional of a more easily boiling process. Okay, so the next there is a fourth type of distillation. Here there's a steam distillation. Steam distillation. This steam distillation, actually the compound has a maximum boiling point. If the compound has a maximum boiling point, we cannot separating as a normal as well as steam distillation, normal distillation as well as fractional distillation, reduced pressure of distillation. But there is a more suitable for that compound if possessing as a more boiling point. For that kind of the compound we can get in the separating this steam distillation. Okay, actually one thing you keep in your mind, this GOC topic of theoretical part in that purification of organic compound. This is not that much of kind of that much of essential. So must be focused on that previous videos covered topic. Okay, so the remaining only one topic is presented in this GOC. For that is a Geldal method, Dumas method, Gary's method. That is under the category of the molecular analysis of organic compound. Okay, okay. Thank you. If you like in this video, you can subscribe and share your friends. Okay, thank you to all.